Okay, so welcome back. This is part 2 in my review of the Koolertron CJD S66 signal generator. Now, as I mentioned in part 1, it is fairly similar, if not identical, to some of the other signal generators you'll see on the market, especially like the JuneTech or JuneC JDS 6600. And in fact, the software, which is one of the things we're going to talk about in this part 2, is labeled, for this Koolertron, is labeled JDS 6600, which is the JuneC or JuneTech. So I'm guessing it's one device with some tweaks, but it's all one device and one set of software. There might be some different software, but you need to look around. So anyway, we're going to talk about some hidden features that are really kind of impressive. This was a $100 device, and I think the JuneTech one is also about $100. We're going to talk about the software you can run on your PC and hook it up to to the signal generator via USB. And I think that's where you do most of your what's called arbitrary waveform. You design your own waveform. And it's got a lot of functionality. It's really kind of surprising. Unfortunately, the software manual is absolutely horrendous. It's in English, but it's by somebody who obviously can't speak English. So it's impossible to figure out. However, I figured quite a bit of it out. So we're going to lead you through how to install it and how to use that. And then we're also going to talk about some of the other features from the user interface and the front panel of this that you can access. It does have some nice stuff in it. So the first thing we're going to talk about is the software, and this is the user interface for the software. Actually, you can configure it. You got a control panel. You got the extended measuring functions, and arbitrary waveform generator tab, which we're going to focus on in this video. In order to get this software, as I mentioned in the last one, you go to amazonfiles.s3.amazonaws.com/dds.rar, and I got this from some questions on Amazon, and the vendor responded multiple times. And I've downloaded this. I've checked it doesn't have any problems, no viruses with malware and it seems to be fine. It works. Works quite well, surprisingly well. So when you download it, you're going to get this in the DDS file, okay, in the DDS folder. CH340 drive, English, these are the instructions, the Visa connection, and then setup.exe. Now, to install this, first of all, of course, you got to connect the USB into the device and into a USB port on your computer. All right, that's step one. Next one is if you go in here, you'll see some setups, but I don't think you're supposed to do that. I would double click on this main setup under the DDS folder, setup.exe, yes, and you will get this thing that asks you to select English or Chinese. So I select English, and it leads you through. You click on these in order, and it installs step one, the USB driver, which is one of these in here. Then installs the NI Visa, National Instruments Visa application, and then installs the main program. You can see it's a JDS 6600 is the name of the software, and that is the other manufacturer. So, it's all the same thing. Quick guide, I click on it, and it doesn't give you anything. So what I would do is to install this, click on each one in succession, and you should get everything installed fine. It worked fine for me. And when you're done, just hit exit and then run. This is going to install a JDS 6600 icon on your desktop. And all you got to do is run that, and you will get this. Okay? So the first thing you do is you configure it. All right? And here's where you can configure it. Now, this is going to install the USB driver, but it's going to be installed as a COM port. So you need to go to your device manager to the serial COM ports and find out which COM port this USB device has been installed to. So if you go into your device manager, you just type that into this search bar and you get device manager, and go down here to ports, COM and LPT, and you will see you've got a USB serial CH340, and you recall that was one of the softwares it installed, and it's at COM4. So remember that you've got this thing recognized on your COM4 port, which is and it's a serial device. So you go back in here and you click the drop down. Now, one thing you got to know about this software, if you don't click in the exact right spot, it might not respond. So I get that quite a bit with this. So click right on the arrow and hit COM4 and connect, and it should give you this response. Normally this is black when you start it up, and it should say I've got a JDS 600, mine's at 15 megahertz, and serial number, and then you're good to go. It's successfully connected. So then you've got the control panel, and it's pretty cool. You've got, on the left-hand side, you've got channel 1 output, and on the right-hand side, you've got channel 2. And you can synchronize these sliders down here, synchronize. In other words, they take whatever on channel 1 and copy it over and synchronize it to channel 2. Not sure why you want that, but so here you've got the buttons to select what you're going to vary. It's like on the front panel of the device where you've got the 2 buttons for channel 1, channel 2. Those are the same things. So you can change the frequency, you can change it to kilohertz, megahertz, microhertz, or millihertz and microhertz, amplitude, duty, x-axis dots, and we're going to talk about that in a bit. Basically, you see that this goes from -1 to 2048 dots. So you're going to generate these signals on a XY chart, and you're going to use dots to describe the relative dimensions of the waveform. So we'll talk about that in a bit. So here you basically adjust everything, okay? And we'll come back and show you when we generate a wave, we build our own waveform. You can come back here and you can vary it. And this, once you select this, it will be sent out to the actual signal generator, and it will appear on your scope or whatever. So right now, this full wave rectifier is appearing on my oscilloscope, this waveform. So the next tab is extended functions, like measuring the counter, where you send an input and it does a counter, or you measure frequency, bursts, sweep frequency, where you can set an output sweep frequency, and then a pulse function. We're not going to talk about that right now. We're going to jump over to the arbitrary waveform generator. Now, if you look at the instruction manual on this, you probably won't understand it. It is very poorly written. So, the basic concept here is, let's take, for example, we want to generate an amplitude modulated waveform, all right? So we're going to need 2 waveforms, a lower frequency modulating waveform, and a higher frequency modulated waveform, okay? And we're going to want to multiply those 2 to get the AM waveform. So we're basically going to want to bring a sine wave into this center display and set it up to be the right relative frequency, and send it over here as waveform 1, and then do another one, bring another sine wave in at the other frequency and send it over here, and then hit multiply to multiply those out, and that will give us our AM waveform, okay? You got to hit that math button and it will multiply it and generate, and we'll go through and do that. Now there's three math operations you can perform. You can add these two waveforms, subtract them, or multiply them, all right? Now, you can also hand draw a waveform. Now, I don't know why you would want to do that, but you can hand draw it by hand, okay? You can go like this, all right? We're not going to discuss that because, well, we'll show you how to do it. But the other thing is you can specify a waveform based on its X and Y points. And we'll talk about that. So I've got this on here. I'm just going to hit reset and go back to 0. So let's start out with a amplitude modulated waveform. First, what we're going to do is we're going to generate the modulating waveform, basically a low frequency sine wave, all right? Now, you can see over here, I can pull in any waveform I want to. I can pull in a sine, a square, triangle, a ladder, any of these built-in waveforms, and I can modify it, all right? So you can also see there's an X0 and an X1. What that means is, in this case, I want the sine wave period to go from X0 of 0, which is over here on the left, to X1 of 2047, which is over here on the right. Okay? Now, I can change that, but for this first one, we're going to leave it. So we're going to have one complete period of a sine wave, and that's going to be the modulating waveform, all right? So 0 to 247, I want a sine wave. Get wave, and there it is. It automatically pulls it in, gives it an amplitude of 1. Okay? So we've now got the modulating waveform, and I'm going to hit this arrow and put it over here. Okay? Now, I want to have the modulated higher frequency waveform. So how do I do that? Well, here's where you have to be thinking in terms of converting between these points and relative periods. So for example, in this case, we said 2047 samples or points is one period of this waveform, okay? So if I want to have a high frequency that is, say, 10 times the frequency of this, then I would have a period that is only, say, 204.7 points, right? Because 204.7 times 10 gives 2047. So we'll say 0 and 205 and get waveform. And you can see it gives us a sine wave from 0 to 205, all right? Now, how do I get the rest of it? Okay, I want to generate multiple waveforms to fill this up. Well, you can see here it automatically increments to now 206. 206 to 411. So if I just click this, it generates another period and generates another period and generates and generates and generates. And that's all you do to build a your modulated waveform. So now you're all set, and you can send that over here. So now you've got the modulating and the modulated, and I've got it on multiply. So I do math, and there you go. You've got your AM waveform with the modulated as a frequency 10 times the modulating. Now, keep in mind that the way you convert from these points to actual frequency is when you go back into the control panel, or you go on your actual waveform generator on the front panel and you adjust the frequency, and that's where you control it. So these are all just relative numbers, okay? We've got relative periods. So now what we can do is, now that I've got this waveform, I can now write that to my hardware, to the waveform generator, and it will store it. And I can put it in any location I want. And you can see if I scroll here, I can go from location 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's a whole bunch of storage locations. I think it goes up to 99 or something. Well, okay. So you can put it in any location and it will automatically send it. When I hit write, it will send that waveform over the USB and store it in your hardware, in your waveform generator, and you can access it. It will save it, and you can access it by just going to storage location. In this case, I could go to, I'm writing it, and you can see, hey, it's doing it. I get a beep from the device, and it's just written this waveform into storage location 8 on the device. So then all I have to do is call it up, and it will appear on one of the outputs, one or both of the outputs. So now let's go back to control panel, and it automatically senses that on channel 1, I have an arbitrary, it's called an arbitrary user-made waveform. And on my scope right now, this AM waveform is appearing. So now that we've got it appearing and stored in the device, we can go here and we can adjust the frequency. All right, so let's adjust this and it will adjust the frequency, and you can see this lights up as it sends it to the device. So now it's up to 10 kilohertz, and you can see on this the scope that it's responding to that. So again, you can adjust all this stuff. You could send it over to channel 2 by do waveform sync, and now it's appearing on both channels. One is 10 kilohertz and one is 1 kilohertz. Okay, so really nice functionality here that you can generate waveforms. Again, there are some limitations, but just so you know how it works. Now let's reset that. And again, we can do anything we want here, but what I'm going to do is do a customized polyline. All right. So in this case, what I can do, let's say I want to generate a sawtooth waveform that goes up to 0.5, and it's 400 points. You know, just pick a number. So what I can do is I can say the starting value is x0 is 0, and well, let's do it to 200. And this goes to 200, and y0, which is the beginning value on this y-axis, is 0, and we're going to set it up to 0.5, 0.5. Generate waveform, and there you go. We've got from 0 to 0.5, we've just generated a sawtooth. And then I can say, you can see it's all automatically incremented for us. So I can get waveform, get waveform, get waveform, get waveform. And there you go. You've got your repeating waveform. And I can send that here, and I can multiply it, and that's what you get for your waveform. Between this guy, and you multiply a sine wave, and you get this whatever. So really kind of cool. You know, you got to think about how you're going to generate this stuff. But that's basically some of the points about the arbitrary waveform generator. So you can also, down here, you can see you can read a waveform file into this and use that as a starting point. Again, you know, this is all up to your imagination, how you want to do it. I can pull in a half wave rectification, and I can modify that. Now, again, you can hand draw stuff. All right. So let's reset, get waveform, and let's say I want to tweak this, and I can just run this line across here, and it's redrawing this sine wave. Again, don't ask me why you want to do this, but you know, it's something you can do. Okay, now there are a couple more important things about this arbitrary waveform generation tab. There's some additional functionality you should know about. For example, this open and save. Let's just start up a waveform here. We've got a sine wave going from 0 to 2049 points. Now you can save this, and it basically saves it as a text file, a simple text file of data points. So it's got 2049 data points with the Y values. And here it is. I just opened it in Notepad++, and you can see here's all the data points. It goes up to 1 and down to -1. And that's basically all it is. So whatever waveform you have in this window, you can just save it and then later on open it, or you can even edit it in your text editor and do what you. So you got a lot of functionality here you can use. So for example, if you've got a waveform that you worked on and you want to save it and then use part of it later, I mean, you could even go in here and erase part of it, or whatever you want to do. So again, it's a simple text file, easy to work with. So just keep in mind you can do that kind of thing. Now the other thing is to make sure you understand the uses of these X0, X1, Y0, and Y1. There's some additional functionality here. Now let's take an example. We've got our waveform, 2049 points. Now what I can do is say I want to add a triangle wave to part of this. So say I wanted to go from 0 to 200 points as a triangle wave. So I just change this to 200 and get waveform, and there it is. It inserts a triangle wave, a full period of a triangle wave from between 0 and 200 points. And then let's say I wanted to add some noise, and I wanted to add the noise from 600 to 800. So I'll go 600 start and 800 end. Get waveform, and there it inserts the value of the noise inside the 600 to 800. Now, the last thing I want to talk about briefly is these in the extend function. Here you can measure frequency, and here's the on button for this measure, and this is for the input BNC connector. If I've got a signal coming in the input, I turn this on, and now it allows me to measure either hertz, frequency in hertz, or cycle in microseconds, or pulse width, or duty cycle, percent. So again, a lot of functionality here, and you turn it off if you don't want it. Sweep frequency allows you, in this case, whatever waveform is set up in channel 1, in this channel, which right now we have a sine wave, what it will do is it will sweep that, in this case going from 1000 hertz to 10,000 hertz over a period of 10 seconds. All right, and if I turn that on and hit this run button, it will generate the sweep on our device. So again, turn it off and then disable it. Same thing with the pulse function. You can generate pulses. So again, a lot of functionality here. So that's about it with the waveform software. Again, very useful. It'll take you some time to get everything straightened out. One other thing I want to mention here is you can set the number of dots. It defaults to 2,000. You can set up to 8,192. And you can change the y-axis from 12 volts, 4 volts. Okay, so you might want to just look through these things and see all the different options. Down here, of course, you can change the step value as you step this through. Right now, you can see up here it's stepping through every 1,000 hertz. You can change that. You can change it to 10 hertz if you want. Just delete that, and now it will go 10 hertz. You can see 46, 56, 66. Okay, so that's about the basics of this software. I think it's very useful and can do a lot if you just try and work through it and figure out how it works. So I hope that helps, and keep in mind that this also applies to like the Junetech JDS 6600 against the the same software as that device. So hope this helps. Take care and have a really good day. Thanks.